Energy is the ability to do work or cause change. When work is done on an object, that means the object moves some distance because of a force being applied to it. So energy is needed to cause change to something. Energy can come in two forms. Kinetic energy, which is energy of motion. All moving objects have kinetic energy. We will look at kinetic energy in a different video. This video is about stored energy that can be used later to do work, called potential energy. An object can have both kinetic and potential energy at the same time. There's a separate video all about energy conversions. We will learn about three types of potential energy, beginning with gravitational potential energy. There's also chemical potential energy, which is storing energy in chemical bonds. There's also elastic potential energy, which is storing energy by compressing or stretching objects. Those are in different videos though. The focus of this video is gravitational potential energy. So once again, potential energy is stored energy. Energy can be stored in gravity. We can easily do this by just lifting an object off of the ground. We know that once released, that object will fall to the ground and will cause change once it hits something. Ouch! Gravitational potential energy, or GPE for short, depends on three things. First, it depends on the mass of the object. That makes sense. Think about a larger object held over your head. Yikes! GPE also depends on the acceleration due to gravity, which here on planet Earth is 9.8 meters per second squared. That also makes sense. If we drop this object from the same height on a different planet or moon, it would cause more or less damage because it will have a different speed when it reached my head. Here on the moon, where acceleration due to gravity is only 1.6 meters per second squared, not 9.8 like on Earth, it would cause less damage because objects accelerate at a lower rate towards the ground on the moon. Finally, GPE also depends on the height off of the ground. If this object was not held as high, it wouldn't cause as much damage to my head. I think you instinctively know that the larger the mass and the higher the height, the more energy it has, the more damage it can cause. It would not be a good idea to stand under a really big piano that's really high off the ground. We can tie all this together with the math formula. GPE equals mass times acceleration due to gravity times the height. The unit, just like all energy, is joules. Now let's try a sample problem. How much gravitational potential energy is stored in a 0.15 kilogram baseball if it is held 2 meters off of the ground? The first thing we do is we list what we're looking for and what we are given. We're looking for the gravitational potential energy. We can see in the problem that the mass is 0.15 kilograms. The baseball is held 2 meters off of the ground. And we know here on planet Earth, the acceleration due to gravity is 9.8 meters per second squared. Next thing we do is we write our formula. GPE equals mass times gravity times height. Then we plug our values in. 0.15 kilograms for the mass. The acceleration due to gravity is 9.8, and we multiply that by 2 meters for the height. 0.15 times 9.8 times 2 equals 2.94 joules. So that's how much joules of energy are stored in that baseball held 2 meters off of the ground. Here's a second problem for you to try. How much gravitational potential energy is stored in a 2.5 kilogram weight if it is held 4 meters off of the ground? I'll get you started, then you can pause the video, do the problem, and then check your answer. I'll give you the answer and how to get the answer at the end of the video. The first thing that you do is you list what you are looking for and what you are given. Try filling in the mass, the height, and the gravity. Hopefully you put in 2.5 kilograms for the mass, 4 meters for the height, and the acceleration due to gravity is 9.8 meters per second squared. That's constant here on planet Earth. The next thing you'll do is write your formula. Gravitational potential energy equals mass times gravity times height. Plug the numbers in, give an answer with a unit. The answer I got was 98 joules. Hopefully you got the same answer. Now how did I get that? I simply plugged in 2.5 kilograms for the mass, 9.8 as g, and the height is 4 meters. 4.5 times 9.8 times 4 is 98 joules.